Okay, so yeah, so we've got 3 coordinate planes, and then we've got this other plane. So let's draw, see what this picture looks like. Good news, I can kind of cheat on this one. I'm going to try to draw this plane. Instead of drawing a normal vector and that kind of game, let me just observe that I can conveniently see the x-axis intercept is 4, right? And the y-axis intercept is 3, and the z-axis intercept is 12. So I'm just going to put those points down. There's 4, there's 3, and there's 12. And I'm interested in how those planes intersect the coordinate planes, because those are the other sides, and I get that this is my solid here. That. Okay. Actually, that didn't help. Okay. Let me. Come to think of it, I'm just going to erase all the colors. Okay. Okay, now, which way to slice? Let's look at our equation, and remember that whichever variable we put on the inside, we're going to have to solve for that in terms of the other variables. So I have an ever so slight preference to solve for z, right? Because then I don't have to deal with fractions as much. So let's do our dz slicing on the inside, and that means we'll put dx and dy on the outside. Here's another way to say that. I'm going to think about the projection down here into the xy plane. Right? And so this integral, what is my integrand? X squared e to the yz. Fine. We're going to do dz on the inside, dx, dy on the outside, and the x and y bounds, what I'm going to put here and here is going to come by looking at that picture. Okay. All right. So, in fact, let me just redraw that picture. I mean, I don't need the three-dimensional part of that. Let me just do this. And in the xy plane, let's see, this intercept was 4, this intercept was 3, and so here's that's my projection. This is what I need to look at, in other words, in order to get the x and y bounds. Everybody good so far?
Yep.
Okay, so now, which one do we want to do first? I guess it doesn't matter. It looks like I've made a... Where am I going? Here it is. I seem to have already made a choice. We're doing our y slicing first. That was arbitrary. But so the range of values of y, well, y starts at 0, and y ends at 3. So y goes from 0 to 3. Yeah? Right. Okay, now we pick a y slice. Let me get rid of all that. So for a particular value of y, wherever that might happen to be, now I want to know what's the range of values for x. Well, x starts there, ends there. Okay, what can I say about that x coordinate, and what can I say about that x coordinate? Well, the first one's a freebie. This one, whoops. X1 is clearly 0, right? For x2, I'm going to have to do a little bit of work. This x2 that I'm interested in is defined by that point. That point is on this line, and that line has, well, I've got to figure out what that equation is. And it's where this equation has z equals 0. So that's easy to write down. It's 3x plus 4y equals 12. Okay, now keeping in mind what I'm interested in there is the x coordinate. So I need to solve for x. there, and then I get is 12 minus 4y all over 3. Yeah. Okay, so that's the upper x bound, 12 minus 4y over 3.
Is it better to not simplify that?
Oh, it's not clear if, I mean, you could pull the 12 out of the fraction, I suppose. I'm not clear if that's necessarily simpler.
Okay.
It's different. That's kind of a personal preference, though. Yeah. There's all sorts of rules about simplification that are arbitrarily made up by high school teachers. No particular reason. They told me one time that it's some sort of crime against math to have a square root in a denominator. I don't know why. I have no such rule. Yeah, like 1 over the square root of 2. I think is a very natural way to describe that number. That would have been, I was told that I must rewrite that as square root of 2 over 2, which to me seems weirder. But anyway, so yeah, no problem in this case.
Okay.
Yeah. Okay, so now we've got our x and y bounds. We got those by looking at this projection. Let's see here, this projection here. I thought I hit the green. There we go. Looking at this projection down into the xy plane. That was this projection down here. And now we have to figure out, okay, given an x and a y, in other words, given a point on this projection, let me zoom back in. Given a point on that projection, what's the corresponding range of values for z? And, well, you know, you just got to identify your points. There's the lowest value of z. There's the highest value of z. What do we know about these points? Clearly, that one is z equals 0. Right, so our lower bound is 0. The upper bound is the one that's a little bit more interesting. That point, what I know about it is I know that it's on the plane. 3x plus 4y plus z equals 12. And keep in mind what I'm interested in is the z coordinate. So I've got to solve for z. And that z is what turns into the bound, and it's 12 minus 3x minus 4y.
And then you evaluate all of that to get the result?
If you wanted to evaluate it, you would, but the question said do not evaluate, thankfully. Yeah, so we don't have to crank it out. Yeah, very often I like to focus students on just one particular phase of the problem.
Yeah.
Yeah. All right, everybody happy on that one?
Can I go over